Okay, thank you very much, James. Thank you very much to the organisers for the invitation. It's very good to be here, and it's a very interesting subject for a symposium of this sort. Here we go. Okay, so I hope you'll permit me to give a couple of slides of introduction to CODATA, and then to talk about some of the challenges that James has highlighted about open data from an international perspective, and in particular about the challenges and opportunities that are present in the modern world, really due to the technological capacity that we have to create and share data, the so-called data revolution. So that sets the frame. I'll talk about CODATA activities and some of the imperatives that other organizations have talked about and have presented in reports that you may be aware of, and then talk more specifically about the sort of things that CODATA is doing. CODATA is an offshoot of the International Council of Science. In the jargon, we're called an interdisciplinary body. CODATA stands for the Committee on Data of the International Council of Science, but we're a lot more than a committee. We do have an executive committee, but our activities have really grown a great deal beyond both the original remit and the description of being a committee. We were actually founded in 1966 with a very specific remit to look at the availability and the quality of data, largely in the physical and chemical sciences, but very quickly the remit and the scope of CODATA expanded considerably. I'll talk in a moment about the sort of activities that we'll do, but I'll just mention in response to what James said about the OECD guidelines. CODATA has done a lot of work on data policy internationally and specifically with our member countries, and we were very much involved in the workshops and the authorship of the OECD guidelines. In fact, a present and former member of the executive committee, Paul Uller from the US and Mark Thorley from the UK, were among the principal authors of that document. We have a new executive committee, newly elected. I've just come back from the International Data Week in Denver, which was a large conference which we organised in partnership with the Research Data Alliance and the World Data System. At meetings around that conference, our new executive committee was elected, and we're very pleased that that's showing an increasing membership from Africa. We now have a South African and a Kenyan member of the executive committee, and we've got a new set of task groups which address a number of issues relating to data policy, to data management, and to scientific issues around data, and particularly in relation to activities in developing countries and Africa in particular, and I'll talk a lot about that. The president of CODATA is Geoffrey Bolton, who was the lead author and chair of the Royal Society's report on open data. No, what is it called? Science as an Open Enterprise. There's so many reports that we've been involved with, which made a big splash when it was published in 2012. Had a considerable effect on data policies in the UK and internationally. It was picked up by the G8 science ministers specifically and went into their text on open science and data sharing, and directly influenced the Horizon 2020, the European Commission's Horizon 2020 data policy. So that report identifies the challenges and opportunities which are created by the digital revolution and makes policy recommendations and urges that science systems as a whole adapt to those challenges and opportunities. And really that's going to be the theme through what I'm going to talk about today in the context of CODATA activities, is the need to address science systems as a whole. Policy, behaviour and incentives, infrastructure as well, but a lot of the human elements. This clicker doesn't seem to be working. Okay, so CODATA has 3 strategic priority areas of activity, which I've mentioned a little bit. We work in the area of data policies, so we produce advocacy reports on data sharing, as well as studies of the benefits of data sharing, and a recent report which I'll talk about a little bit, Open Data in a Big Data World. We have task groups and other activities, working groups, which work in what we call the areas of frontiers of data science. So that's particular technical or procedural issues about data management or about data analysis. So for example, we have a working group on which has produced a uniform description system for nanomaterials, for materials on the nanoscale. So that's essentially created an ontology for describing nanomaterials across subject areas. So we do that sort of technical work as well. We have a journal, the Data Science Journal, which is trying to position itself as a journal, as a forum where people can discuss issues around data in all areas of research. And by data science, we mean data science very broadly, the science of data as it is used in research. And we organize a biannual conference, CODATA, which just happened in Denver, but increasingly we'll be organizing regional conferences with CODATA member countries on odd years, whereas CODATA will happen on even years. And we do a lot of work on capacity building and training. So it's not just CODATA, the report on science as an open enterprise or open data in a big data world, that's urging that we respond to the data revolution. I'm just going to mention very briefly this report from the UN Expert Advisory Group on the data revolution, and essentially what accommodations national statistical agencies and national science systems should make in order, firstly, to take advantage of the data revolution, but specifically for two objectives. Firstly, in order that we can better measure the achievement of the Sustainable Development Goals, and secondly, in order to encourage activity, whether economic or scientific or developmental, that can help us achieve those sustainability goals. It's an interesting report that I recommend that you look at if you're not already aware of it. In detail, it addresses and makes recommendations on the changes that need to be made in order the data should be more available, in a timely manner, better described, so it's more useful, as you can see in that list of issues to be addressed. But above all, it urges that this is an ethical issue, and it's an issue on an international scale, and it's an issue about equality or equality of opportunity or equitability on an international scale. And I think it's worth stressing that quotation, which is the third down. Without immediate action, gaps between developed and developing countries, between information-rich and information-poor people, between the private and the public sectors will widen, and risks of harm and abuses of human rights will grow. So data, accessibility of data, the way we use data is an issue of that sort of ethical importance. Just flag another report as well from GODAN, which is the Global Open Data for Agriculture Network. This is a report that they produced with the Open Data Institute. What I particularly like about this report is, whereas the Data Revolution report gives some case studies but is very high level, this gives some specific examples of how open data is being used in agriculture to improve responsiveness and the effectiveness of agriculture. And again, it makes the same sort of recommendations, specifically that open data as such isn't enough. That considerable effort needs to be put into the way data is collected, the way it's described, and the way it's stored and made available. And also that we need to consider the way that the benefits redound from open data and the equitability of the way those benefits are realized. I wanted to mention very quickly some of the economic benefits of data sharing, apart from those broader international issues of how we share data and who benefits. There's a lot of evidence showing more generally the benefits of open data. This is studies relating to the benefits of sharing Landsat data, Earth observation data from the American Landsat program. Until 2009, that data was chargeable. So to use it, users had to pay to access it. In 2009, USGS made the decision to make those data available, free at the point of use, and usage skyrocketed. They've done in order to justify that policy, they've done a number of studies to estimate the economic benefits of the reuse of that data. And it's, as you can see on the slide, it's in the order of billions. CODATA did a recent report for the Group on Earth Observation, which essentially provided a survey, a high-level survey of the studies that have been done in various spheres about the benefits of open data sharing. And it categorises that literature into areas of economic benefits, social welfare benefits, research and education opportunities, etc., etc. It essentially acts as a annotated bibliography or a high-level survey of the work that's been done. And I think that may be of interest. But the reason I'm stressing this is that if we take this sort of work alongside the Data Revolution report and the Godan report, we can assert on the one hand that there are clear economic and developmental benefits of open data, but on the other hand that we need to be careful about how open data policies are applied and consider the nuanced issues that James mentioned. As I said, CODATA is part of the International Council of Science. We recently produced this report, Open Data in a Big Data World, for a consortium including the International Council of Science, International Social Science Council, the Inter-Academy Panel, and the World Academy of Sciences. It's a little bit of an acronym soup, but those are 4 international organisations which claim to represent in one way or another key scientific activities. That report makes, we think, a powerful case for the transformations that I've been talking about, for the changes, the systemic changes in science systems. It lays out a set of principles and, above all, responsibilities for particular stakeholders, and addresses a number and recommends a number of enabling practices for how the vision of an effective open data or open science can be realised. There are translations of a short version of the Accord in a number of languages. But above all, we invite institutions, not individuals, but institutions, research institutions that represent researchers and people that care about data, to endorse that Accord. And we've had over 100 endorsements from international scientific unions, from national academies, etc. But we're still continuing the campaign to seek endorsement. We think that's not just a paper exercise, that it can actually help concretely influence policies and behaviours in this direction. An example of that is the response that the International Union of Crystallography made to the Accord, and really described how the issues raised play out in their particular research area. Now, what I'm going to do for the remainder of the talk is to talk about specific CODATA activities which emanate from that work. The Accord makes a great deal of emphasis on the human aspects. Of course, there are technical issues, as James mentioned, but there are very specific human aspects which we seek to address, and particularly in the work that we're doing in Africa and Latin America. Is that going to be... Okay, that's fixed. So I think this is adapted from a paper that colleagues here at the Oxford Internet Institute did for an OECD study on data sharing in neurosciences. But it demonstrates nicely that, I mean, let's remember that technology challenge is still pretty big, but the human challenges, the processes and organisation, the people, skills, incentives, mindsets, are very major challenges. That perspective as well as the analysis that we put into the Open Data in a Big Data World Accord, has led to some of our subsequent activities in Africa and with other countries. We're using that approach in a coordination activity that we're doing with the Polish Science and Education Ministry, organising a workshop in the spring of next year, really a stakeholder workshop to bring together important stakeholders within Poland, the funders, the academy, the research institutions, etc., to discuss these issues and, using the Accord as a starting point, then to see how this plays out in a Polish context. And I'm going to say that repeatedly. How do these issues play out in a given context? So we're organising the workshop really in order to set the ball going, put certain principles and practices that can be recognised on an international level on the table, and then work with the stakeholders to see how this can be applied, adapted, nuanced, and given a particular Polish flavour. So the design of that workshop has been done. We're in the process of organising it. It brings together stakeholders and will set up working groups in those particular area of enabling practices which were identified as being particularly important. We're doing a similar activity in Africa as a whole, with funding from the Department of Science and Technology in South Africa. Nearly €500,000 over 3 years, and we're likely to get some additional funding from the Dutch Academy of Science as well, as part of a partnership deal between themselves and the South African government. That initiative has 4 work packages, essentially. This activity of co-design of data policies. We do see data policies as not necessarily top-down, as participatory, and but nevertheless as the starting point. We're going to do work on incentives frameworks, which I'll say a little bit about in the context of data citation. Training activities, both for the researchers themselves, the people that support researchers, and for decision makers and managers. And we'll also be preparing a research data infrastructure roadmap on an African scale. So in what's left, I'll talk about those 3 areas. I've said a bit about data policies already, so incentives, training activities, and the idea of data roadmaps. So one of the real challenges about data availability and data sharing is not necessarily the amount of work that goes into it, though we don't want to underestimate that, but by and large research institutions and researchers put a lot of effort and a lot of work into what they do. It's just a matter of priorities. And those priorities are determined by the reward system. And the reward system currently recognises articles in so-called high-impact journals, but not necessarily the data that underlies those articles, even though those data may have more significant, more enduring long-term use and be a greater contribution to science and research as a whole than the article that describes the experiment or the process that created them. One part of adjusting the reward system and integrating research data in the process of scholarly communications and the assessment of contribution to research is data citation. It's not the only one. I don't want to give the impression that this is a single solution, but it's a significant part. By and large, data sets, when they're created, are not effectively cited in the literature, though there is imminent change. And they're not effectively incorporated into the assessment of scientific contribution. Data citation is a start. CODATA produced a report a couple of years ago, Out of Sight, Out of Mind, which has that nice little quote in which I won't use time to read out, but it's worth a look. And we also contributed a great deal to something you may have heard of, the Joint Declaration of Data Citation Principles, which was curated by an organisation called Force 11. What we've done subsequently is, again, the same sort of process of organising stakeholder workshops in different countries in which we work. So in order to move from principles to practice, we've convened a series of workshops bringing together stakeholders, funders, decision makers, policy makers, research institutions, researchers themselves, publishers and journal editors to try and discuss these issues and potentially just practice. This is the sort of thing that CODATA tries to do in order to be as effective as possible, to design an activity according to a certain format and then reproduce that effectively in some of our member countries. So in the last 12 months, we've organised 8 of such workshops in China, Australia, Japan, India, South Africa, USA, Israel and Russia, and there's 2 more coming up in the Northern Hemisphere autumn in Finland in November. These workshops raise the issues, and in some instances we hope that they'll lead to significant change among the practices of some of the partners. We also do a lot of work in terms of training and the development of data skills, both for researchers themselves and for people that work with researchers, whether that's data librarians or trainers in institutions. This is an activity that we did with the Research Data Alliance. And it presents this vision that there are a set of skills relating to data that increasingly all researchers need. We're very aware of the software carpentry and the data carpentry movements who create small, short, reusable courses, and that those activities are being picked up by a lot of research institutions. There may well be activities like that going on in Oxford, and there certainly are in a number of research institutions. Short courses that researchers can attend very quickly and pick up key skills. We looked at what software carpentry and data carpentry deliver, as well as the Digital Curation Centre, and said this is great stuff and we really like the approach, but perhaps the curriculum should be a little bit broader. So our assessment was that the core data skills include the principles and practice of open science, research data management and curation, development of a range of data platforms, techniques of large-scale analysis, statistics, visualization, modeling techniques, software development and data annotation, etc. So we put together this curriculum for a 2-week course. People that do that won't become experts in those 2 weeks, but they'll have a sufficient introduction to be able to go away and do effective self-learning. So we ran the first of these schools, School of Research Data, at the International Centre of Theoretical Physics in Trieste in Italy in August, with sponsorship from the organisations listed. The ICTP is an international campus which runs a number of training courses and conferences and workshops of this nature. We were able to, through sponsorship, to open doors for that course for 70 students from all around the world. And this is slightly self-indulgent, but it was a real success. There's more information at that bit.ly link about the program, and there's quite a photo gallery from that course. The important thing is that the feedback was extremely good, and we will be repeating that course at Trieste for the next 2 or 3 years at least, and we've been invited by the ICTP campus in Brazil to run the course in December next year as well. One of our key objectives was to involve some more advanced students who had permanent positions at their institutions in various countries and that would act as future hosts. And we have a number of colleagues that we'll be working with in Botswana, in India and in other countries to put on similar courses. 5 minutes? Yeah, okay. So that's a little section on research data infrastructure roadmaps. This is the 4th work package of the activity that we're doing, the coordination activity that I described in Africa with funding from the South African government. There have been some studies in Europe and indeed a report called SIRIA in South Africa, which in the South African context tried to look at key research priority areas and to determine the research infrastructure that would be necessary to support these. We think this strategic approach is really important in a number of African countries, and there are a number of international initiatives which are beginning to do this sort of thing. For example, the Square Kilometre Array, which has been developed in Australia and in South Africa, the Major Radio Telescope Initiative, is also having outreach activities in a number of African countries. There's an institution called AIMS, the African Institute of Mathematical Sciences, which has centres in a number of African countries and is seeking to prioritise various research activities in relation to mathematical sciences and in their applications. What we're seeking to do with this activity is to provide an overview which can be used by those countries to assist coordination. But of course we'll be stressing that the infrastructure developments are only part of the big issue, part of the overall issue rather. But it's nevertheless, particularly in the African context, that those infrastructure issues are addressed, but they're designed to meet the research objectives and the priorities of the countries involved. One of the questions that's important to ask is, where should research data go? And what is the role of international, national, or institutional research data infrastructure? And this is both the infrastructure that supports data through the life cycle and that looks after it in the long term. I won't labour that excessively, but that's one of the key questions that that activity will be addressing. And then finally, we need to ensure that data infrastructure is sustainable. We have a project at the moment with the OECD Global Science Forum on sustainable business models for data repositories. Since the digital revolution, post-development of the internet and the web broke upon us, there have been countless exercises in countless universities that have digitized materials, that have created databases, and a lot of those are no longer accessible, or no longer accessible without a great deal of effort. Sustainability of digital resources, of digital infrastructure more generally, and specifically repositories that look after data, is a major issue. With the development of open data policies, the Horizon 2020 data policies, etc., the demand for data repositories is increasing, and we need to ensure that our data infrastructure is sufficiently scalable. At the same time, we're not convinced that the funding which is currently being allowed for data infrastructure will be sufficiently elastic unless there are changes. That may imply changes in funding policy, and we hope so to some extent, but it'll also imply changes in the way that data repositories are funded and the mechanisms for funding that, and it's precisely those mechanisms that we're seeking to address. A number of data repositories, the Archaeology Data Service in this country, the Arabidopsis information resource in the US, have been obliged to change their business models. They've been obliged by their funder to change their business models. And other well-known data repositories are looking at alternative means of funding. So we've got a 12-month project with the OECD to try and address these issues. How are they currently funded? What innovative income streams are available? But above all, how does funding of data resources fit into the broader system of funding science and the broader economic interchanges, if you like, around research and science funding? Do income streams match willingness to pay of various stakeholders? What are the stakeholder groups, the user groups that use particular repositories, and how do they pay? And one of the crucial questions is, if we identify a way of paying for digital repositories which is more sustainable, might it be that those particular ways of paying for them are more expensive overall or in the long run? So we'll be doing that micro and macroeconomic analysis between two workshops, the first of which is in November and the second at the end of March next year. Working on that project is John Hodson, an Australian economist who's done quite a lot of work on the economic impact of data repositories and has a very keen view of how data repositories fit into the broader system of science funding. I mentioned, this is the last couple of slides, I mentioned that because we're also working with our colleagues at CODATA Kenya and at the Jomo Kenyatta University of Agriculture and Technology on the sustainability of their institutional data repository. We held a workshop there 2 years ago, both at JQuat and at UNESCO in Nairobi, which was attended by the then ICT minister, who's now the education minister, Matiang'i, in Kenya. He gave a very impressive talk on the advantages of open data for a country like Kenya, and as a result of that workshop, the Centre of Excellence for Open Data was set up at JQuat, which has subsequently put in place a data repository. But their challenge is sustainability. And that's something that we're working on with them. We don't have all the answers. They don't have all the answers. It's going to be a major challenge. But because they work very specifically in the areas of agriculture and nutrition, they're keen to, at the one and the same time, fulfill the open data mandate and make sure the data is available, but also to explore ways of monetizing applications, APIs, or other ways of enhancing the data and making it more useful for the end user, which means specific farmers or agriculture authorities within the country. This is what we're exploring, and they've got a partnership with IBM to help them do this. We're not yet sure that this will be this can be achieved, that this will be a sustainability model, but it's what we're looking at. And I think it's important to explore these things while being mindful that there are major challenges about sustainability for data infrastructures in an institution like JQuat and in a country like Kenya. Thank you very much.